Hi everyone. In this session, we will solve some numericals related with E.M.F and the combination of resistors. Let's see which are the equations we need to solve this. Okay. So the basic equation is the Ohm's law. V is equal to I into R that we require. Then the equation related with the E.M.F. E.M.F and internal resistance. So epsilon is equal to I into R plus R. R is the external resistance and small r is the internal resistance. And in some place we need the relationship between this voltage drop, E.M.F and internal resistance. So there we can write internal resistance is equal to epsilon minus voltage drop. It's capital V voltage drop divided by I. Okay. Then we need the equation for series and parallel combination. That is Rs is equal to R1 plus R2 plus etc. Then for parallel combination it is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus etc. So these are the equations we require to solve the numericals. Let's see the first question. In the first question, this is a figure given and this is R, this is epsilon and this is internal resistance. And the values are given that epsilon is equal to 2 volt, internal resistance is equal to 1 ohm and external resistance is 4 ohm. Okay, so we have to find when the key is open, what is the E.M.F or the voltage available in the circuit and the current drawn. When this is closed, what is the current available and the voltage. So these are the things we need to find it out. Okay. Now in the open condition, what is the voltage available in the circuit? That is equivalent to 2 volt. Okay. When the key is open, voltage or potential difference is equal to potential difference, that is epsilon, that is equal to epsilon itself, that is equal to 2 volt. We study the definition for epsilon. When it is in the open circuit, the maximum available potential difference is known as epsilon or E.M.F, right? Okay. If the key is open, what's the value of current drawn? It is 0. If the current will pass through the circuit, if the key is open, no. So these are first section when the key is open. Now, when the key is closed, okay. Now, second condition, when key is closed, that is this one, okay. Now, we'll see what is the current available in the circuit, okay. So, for that, we need to consider, if the current available in the circuit, we have to consider this external resistance and internal resistance, okay. So, we have to use the equation epsilon is equal to I into R plus R. Okay. And what we have to find it out? We have to find out the current. So rearrange the equation. I is equal to epsilon divided by R plus R. Now we will substitute the values. What is epsilon? Epsilon is 2 volt divided by R plus R. That is 4 plus 1, that is equal to 2 divided by 5. What is 2 divided by 5? It's equal to 0.4. What is the unit of current? It's ampere. Okay. So when the key is closed, the current drawn in the circuit is 0.4 ampere. Now we have to find out the voltage available in the circuit. Okay. When it is a closed circuit, the voltage available in the circuit is that time it's not depends upon the internal resistance. We are finding out the voltage drop. Okay. We are finding out the voltage drop means outside the circuit how much voltage is available. Okay. So voltage drop is equal to I into R. There we don't want to consider this epsilon and R. Okay, voltage drop is the voltage available in the outside circuit. This is the inside part. This part is only for the cell. Okay, so V is equal to I into R. I, we already found that this 0.4. So we have to find 0.4 and the external resistance is 4. So 0.4 into 4 is equal to 1.6 volt. So when the current or when the key is closed, the voltage available in the circuit is 1.6 volt. So we studied that when the circuit is in use, the terminal voltage is always less than that of the E.M.F. When the circuit is open, this terminal voltage is equivalent to the E.M.F. That's why in the first case we got the terminal voltage or voltage as 2 volt. Okay. Now current is drawn in the cell and the available potential difference, that is terminal voltage available in the circuit, is 1.6. Let's see the second question. In the second question, the E.M.F is given as 3 volt. When the current is drawn in the circuit, the terminal voltage is given as 2.7 volt and current drawn in the circuit is given as 1.5 ampere. We have to find out the internal resistance. So we have an equation. R is equal to, internal resistance is equal to E.M.F minus terminal voltage divided by current drawn in the circuit. So directly we can find out the value. 3 minus 2.7 divided by 1.5. Here we will get 0.3 divided by 1.5. 0.3 divided by 1.5 is equal to 0.2 ohm. This is the resistance. So the unit of the answer is ohm. So the internal resistance of the cell is 0.2 ohm. Let's see the third question. For the third question, this is the figure given. Okay. So E.M.F is equal to 1.8 volt. Internal resistance is given as 2 ohm. And here we have connected an ammeter and it has a resistance of, we'll consider it as R1 is equal to 0.7 ohm. And the external resistance is 4.5. I'm just writing it as R2 is equal to 4.5 ohm. We need to find out the potential difference. So in the question, if potential difference mentioned means that is equal to terminal voltage. Okay. So when we find out the terminal voltage, this internal resistance never consider there. Okay. It never, that R plus molar never will be there. Only we have to consider the external resistance. Okay. Or else if you want to find out the E.M.F, that will be particularly mentioned. In that case, you have to consider the internal resistance. But if you want to find out the current drawn in the cell, we have to use the equation epsilon is equal to I into R plus R. But terminal voltage means V is equal to IR. That simple Ohm's law we need to use it. Okay. Then we have to find out the current drawn. Okay. Let's find out the total resistance or current drawn. So if you want to find out the current drawn means we have to consider the E.M.F. That equation epsilon is equal to I into R plus R. This R means we will write R is equal to 4.5 plus 0.7. Okay. So we'll substitute the values, or I is equal to epsilon divided by R plus R. What is epsilon? Epsilon is 1.8 divided by 4.5 plus 0.7 plus internal resistance 2. Oh, that is equal to 1.8 divided by 7.2 will come. If we add all these three values, we will get 7.2. And when we solve, we will get it as 0.25 ampere. So, the current drawn in the circuit is 0.25 ampere. Now, we have to find out the terminal voltage or potential difference. So for that, so I'll write it here the value 0.25 ampere. Okay. Now for finding out the voltage drop, sorry, not voltage drop, terminal voltage or potential difference, use the equation V is equal to I into R. Okay. So this R is only meant for this external resistance. Okay. So I is 0.25. What is your external resistance? 0.7 plus 4.5 into 0.7 plus 4.5, or else we can write as 0.25 into 5.2. When we multiply it, we will get it as 1.3, and the unit of potential difference is voltage. Okay, so this is the way how we have to solve for potential difference and current drawn and even for E.M.F. So keep that in your mind. Let's see the next question. In the fourth question, a cell with an E.M.F epsilon, the value is not given, and an internal resistance is connected. When this is connected with an external resistance of 1.9 ohm, I am marking it as R1. The current drawn in the circuit is 0.5 ampere, and if this is connected to an external resistance of 3.9 ohm, the current drawn in the circuit is 1 ampere, and if this is connected to an external resistance of 3.9 ohm, the current drawn is equal to 0.5 ampere. So these are the two set of data given. We have to find out the E.M.F and internal resistance. So with this data, we will make two equations. So according to our first data, epsilon is equal to I into R plus R. Okay. So we will write it as epsilon into I is 1 ampere, external resistance is 1.9 plus R. Or we can write it as epsilon is equal to 1.9 plus R. Consider this as a first equation. Okay. When this internal resistance is connected to external resistance of 1.9 ohm, the current drawn is 1 ampere. We made one equation. With another set of data, same way we will make the equation. So epsilon is equal to 0.5 into 3.9 plus R. Okay. Or we can write it as, we get 1.95 plus 0.5 R. Okay. Second equation. See the first equation, second equation, our left side is epsilon. So we will equalize this equation. So we will get 1.9 plus R is equal to 1.95 plus 0.5 R. So we will keep the R factors together and the other two values together. So we will get it as R minus 0.5 R, because when we take this plus to left side of the equal sign, it will be minus. So same way, that will go minus 1.95 minus 1.9. So 1 R minus 0.5 R is equal to 0.5 R is equal to 1.95 minus 1.9 is 0.05, or R is equal to 0.05 divided by 0.5. This is equal to 0.1 ohm. Okay, so we found the internal resistance is equal to 0.1 ohm. Now we will apply in any of these equation and we will find out the value of epsilon. So let us apply in the first equation. We will substitute the value. It's 1.9 plus 0.1. Okay, what is 1.9 plus 0.1 is equal to 2. So epsilon is equal to 2 volt, or E.M.F in the circuit is equal to 2 volt, and the internal resistance is 0.1 ohm. Let's see the fifth question. So in the fifth question, it's given that we have three set of resistors. R1 is equal to 2 ohm, R2 is equal to 3 ohm and R3 is equal to 5 ohm. We have to get the final value or effective resistance less than 1 ohm. Okay. When we study the theory part, I mentioned that if we are connecting all the set of resistors in a parallel combination, the effective value will be less than that of the least one. Okay, so here they have given a condition, the effective resistance should be less than 1 ohm. So that means less than the least value. So how we have to connect the circuit? The connection should be in a parallel way. Okay, so which equation we have to use? We have to use the equation to find out the effective resistance in parallel circuit. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So let's see what we'll get. 1 by 2 plus 1 by 3 plus 1 by 5. Okay. So what we have to do? We have to find the LCM. What is LCM? It's 30, right? No, 3 into 5 into 2 is 30. So here we'll get 15 plus 10 plus 6. Oh, this is equal to 31 divided by 30. 1 by Rp is equal to 31 divided by 30. What we have to find out? We have to find out Rp, not 1 by Rp. So Rp is equal to, take the reciprocal, 30 divided by 31. When we solve this, we will get it as 0.97 ohm. See, it satisfies the equation. It's less than 1 ohm. Okay, so this is the way we have to find out, or we have to connect it if we need the value less than the least value. If you want the value more than the or greater than the value which is available in the circuit, is connect it as a series circuit. Okay, let's see the next question. Next question is given that three resistors of 2 ohm, each has 2 ohm resistance, connected in such a way that we have to get the final answer as 3 ohm. So we have to choose a combination. Okay, let's try with that. So we have 3 resistors. We'll see if we get the value. So if we compare with the value, it's greater than the least value or greater value, right now. So let's try if we connected in series, whether we'll get the value. Okay. So what's the equation to find out Rs? Rs is equal to R1 plus R2 plus R3, right? So 2 plus 2 plus 2, we will get it as 6 ohm. So this series connection will not work out. If we check out with the parallel connection, the value will be less than 2 ohm. But we should get the value as 3 ohm. So we can use the combination of resistors. Okay. So how can we go for the combination of resistors? Series and parallel. Only 3 resistors are available. So one should be series and other 2 should be parallel. Okay, first one is in series. So here 2 ohm. The other 2s are in parallel combination. So what we have to do if we get such kind of question? First we have to solve this part. Okay. So we'll find out 1 by Rp is equal to 1 by 2 plus 1 by 2. LCM is 2. 1 plus 1. We'll get 2 by 2 is equal to 1 ohm. Okay. Now, along with this solution, we will solve the figure also. It will be easy for you to understand. So, first one is here 2 ohm. Instead of this one, now we have a single value. So, 1 ohm. Now, how is it easy to find out the value? Now we have to use a series combination R1 plus R2, that is 2 plus 1, it's 3 ohm. Did you get the answer which is given in the textbook? Right? No? So, if we use a parallel combination and a series combination together, we will get the desired value. So, this is the way we have to solve the numerical. Let's see the next question. So, in this question, it's given that 3 resistors connected in series and likewise 4 set of combination connected in parallel. Let's draw the figure first. Okay, so 3 set 1, 2, 3. 3 resistors connected in series, likewise 4 set connected in parallel. Okay, 1, 2, 3. Okay, so like this way, 4 set is connected in parallel. Okay, and each one has a resistance of 2 ohm. We have to find out the effective resistance. How to find out the effective resistance? We have to do the parallel combination. But before that, we have to make it as a single resistor, right? So, individually, we will solve these all 4 set. Okay. How can we solve this? It's series connected. So, we just want to add it. 2 plus 2 plus 2, 6. Right? So, instead of these 3 set of resistor, I am going to draw a single resistor. This is 6 ohm. What happened to the second arm? There also 6 ohm. Third arm is also 6 ohm. And fourth arm is also 6 ohm. Right? So, we solve the first section. Then what we have to do? Now, we have 4 resistors connected in parallel and each bears 6 ohm. Now, we will find out the parallel combination, effective resistance in parallel combination. Okay. Which is the equation we have to use? 1 by R is equal to 1 by RP is equal to 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. Here we can take 6 as our LCM. 1 plus 1 plus 1 plus 1. So, we will get 4 by 6. That is RP. So, 1 by RP is 4 by 6. Then, what we have to find it out? We have to find out the resistance or RP. So, RP is equal to 6 by 4. Oh, that is equal to 1.5 ohm. Okay. So, you have to read the question, understand how the resistors are connected. Then, draw the figure, solve it. Okay. Let's see the 8th question. In the 8th question, this is the figure given in the question. We have to find out the effective resistance. Okay. So, here few are connected in series, few parallel, but in that also series connection is there. So, we will solve by drawing the figure. It will be easy for you. Okay. So, first what we have to do? We have to solve the parallel connection. But in that parallel connection, we have the series combination. So, we will add it and we will make it as a single resistor. Okay. So, here A, let it be A here. First 1 ohm is here. Then on the top 1 ohm and 1 ohm connected in series. So, what is the value of that? That is 1 plus 1 plus 1 is 3 ohm. Okay. So, instead of this full path, I am just drawing a single one, that is 3 ohm. And in between we have 2 ohm, let it be there. Same way down part it's 2 ohm, 2 ohm and 2 ohm. So 2 plus 2 plus 2 it's 6 ohm. So instead of that 3 set of resistors, I am drawing a single resistor with the value 6 ohm. Okay. So once it is over, again 1 ohm and B. Okay. Now it's easy to solve it, no? So how can we solve this? 1 by 3 effective resistance. So 1 by Rp is equal to 1 by 3 plus 1 by 2 plus 1 by 6. Take 6 as the LCM. Here we'll get 2 plus 3 plus 1. Right? So that's equal to 6 divided by 6, or Rp is equal to, same 6 divided by 6 is equal to 1 ohm. Okay. So instead of this value, I am going to use it as a single figure. I'll draw here. We have a 1 ohm, and here the effective resistance we found for this parallel combination, that's also 1 ohm, and we have another 1 ohm here. So not ampere, it's ohm, and this is a V. Okay. Now what's the effective resistance there? Rs. It's 1 plus 1 plus 1, that is equal to 3 ohm. So the total effective resistance available in the circuit is 3 ohm. So when you get such kind of figure, please solve through the figure. Otherwise you will get confused. Find out the value, then draw the equivalent resistance for that. Again solve it and draw the figure. So it will be easy for you to find out the answers. Let's see the next question. So in this question, we have a resistor of 27 ohm. A long length resistor of 27 ohm is available with us. It is divided into 3 equal parts. Okay, now we have 3 resistors. It is divided into 3 equal parts and connected in parallel combination. Okay, so if we divide this 27 ohm into 3, what will get? 27 by 3 is 9 ohm. So each resistor's value is 9 ohm. It is connected in parallel combination. We have to find out the effective resistance. How to find it out? 1 by Rp is equal to 1 by 9 plus 1 by 9 plus 1 by 9. We can take 9 as the LCM. So 1 plus 1 plus 1, that is 3 by 9. Or what is Rp? Rp is equal to, take the reciprocal of that value, 9 by 3 is equal to 3 ohm. So if we connect this 27 ohm resistance into a parallel combination, we will get the effective resistance as 3 ohm. We will solve the rest of the problems in the next session. So such kind of problems you have to practice by own. Refer your textbook, refer your extra reading textbook, see the previous year question papers and solve more problems. Then only you will be able to do within the limited time. Thank you.